So I'm going to do a little segment in each of the pertinent videos throughout this build that I'm going to call Sponsor Spotlight. It's not a paid advertisement or any of that shit. It's just to highlight the items that I'll be using throughout this build that were provided by the respective company. In this video, I'll be going over setting up the Bigtreetech Manta E3EZ using the CB1 board that is currently installed on this Pi 4B adapter that was supplied to me by Bigtreetech a few months ago. They provided me with this, along with the HDMI 5 display, stealth burner CAN boards, and Nomi I'll be using and highlighting in another Sponsor Spotlight segment later down the line. The Manta E3EZ will be using these EZ2209 driver modules, which are a Bigtreetech exclusive product that are designed in a way that they eliminate the possibility of installing your stepper drivers backwards when you're in a hurry, and they offer a more compact design that makes the E3EZ a board that is filled with a lot of features in a very small footprint. As seen in my previous video, I need an adapter plate for the Manta to fit properly into my enclosure, but if you have a Creality Ender 3, these boards are meant to be a drop-in replacement. They run Clipper firmware via the CB1 or Raspberry Pi CM4 module that gets installed onto it, or they can be used to run Marlin firmware without the use of a compute module, or can be fitted with Octoprint if you're a masochist. I'll be installing the CB1 that I already had because Bigtreetech has been so generous over the last few months that I didn't want to overstay my welcome. So I opted to use the board that I already had instead of getting greedy and asking for another CB1 for this build series. That being said, I'm not sure the extra few bucks would have been a make or break, but I feel like little concessions here and there help maintain balance. The installation procedure will be practically identical to my previous CB1 video, so look at that if you're interested in following along step by step. I'll be glassing over the basics and deep diving into the things that are different from the plain vanilla CB1 and BTT Pi, which was so much the same procedure that I removed the larger SD card from the Pi 4B adapter, put it into the BTT Pi, and it worked perfectly. And that's the nice thing about this ecosystem. The fact that all of these products are built on the same architecture makes it simple to configure one after the other. So looking in the manual for the E3EZ, we can see under the feature highlights that it's powered by a 32-bit, 64 MHz ARM Cortex M0 series processor, model STM32G0B1RE. The board takes a 12 or 24 volt input, and it provides sufficient power for a Raspberry Pi. The thermistor circuit is protected in the case of shorted heat bed or heater cartridge connections. You can update the firmware via SD card or use DFU via Clipper's make flash command. A nice thing about it is that it uses either SPI or UART mode with the EZ drivers, and you don't have to change any jumpers for that. There are some ports on there for power loss recovery, filament runout sensor, auto power off, BL touch, RGB, LEDs, and so on. We'll see here that each motor driver can select corresponding voltage by jumpers, and there's a separate motor supply that supports up to 56 volts for the EZ5160 motor driver, which lets you run a higher voltage and therefore achieve greater speeds, more motor torque, and things like that. Looking at this diagram here, we can see all of the motor outputs are on the top, along with a parallel dual Z output right here that runs on the same Z-axis driver. In my case, I'm going to be using true dual Z-axis motors, so I'm going to be using the Z1 motor output as well as the E1 motor output to control Z1 and Z2. In the case of the Anycubic Cobra Max, that machine actually uses a parallel dual-driven Y-axis. So if I wanted to do the same thing on the Chiron, I could replace the Y-axis motor and bracket with two separate Y-axis motors and then drive them parallel off of the exact same output, the exact same driver, without any kind of splitter cables, anything like that. There are two different SD card inputs. There's an SD card input here, and then there's an SD card input underneath this SPI connection right here. This MCU card input is for updating the STM32 firmware, and then the card underneath the SPI port is the actual firmware that runs on the CB1 or the CM4, which mounts here. There's also the 40-pin GPIO section. There's a micro USB section right here that we could use separate to power the CB1. There is a camera and DSI port here and here, but these only work with the CM4. There's an SPI connection and an HDMI connection for running screens. There's only two USB ports on this board as opposed to the 4 that would be on the BTT Pi or the Pi 4B adapter. And it also takes wired LAN, or you can use the Wi-Fi on the CB1. There are 3 controllable fans. that you can program with G-code. So you can have fan 0 for your cooling fan for your hot end. Fan 1 could be the cooling fan for your part. And then fan 2 can be a controllable fan for your electrical enclosure, or a secondary fan if you wanted to run something like the Creality auxiliary fan kit, which mounts on the X-axis gantry rail and provides extra cooling in high-speed applications. You can run it off of that. There's also 2 full-time fan outputs, fan here, and then fan here. So if you wanted to run constant fans, say an enclosure fan or something like that, you can run those full-time here. There are CAN bus ports that I'll be using for my stealth burner. You've got all of the available end stops. You've got an RGB light output for running RGB LEDs. You've got your filament runout sensors for E0 and E1, BL touch port, thermistor inputs, etc., etc. So you can see there's a lot of different features and functionality on this board. And then I'm going to have to pay close attention to the motor outputs on here and then compare those to the stepper motors that I have to make sure that I get everything right, or else there's going to be a lot of grinding and clunking and chunking and what have you. But you can see all of the pinouts available here that we'll be using for setting up the Clipper config files. So you can see there's a lot of different connection options and a lot of different options on the board itself. You can select the motor voltage as to whether it comes from the main DC input or the motor supply input by changing this jumper here. You don't have to use a jumper, as I mentioned before, to switch between SPI and UART mode. There is a jumper that you would place on the board for setting up sensorless homing, which is something that I'm planning on trying to do with X and Y. The Z is going to be using the BL Touch to home itself out, so I don't have to worry about sensorless homing there. So it does go into pretty good detail as far as how to wire in a BL Touch to the BL Touch port and make sure that you have all of your BL Touch wires correctly inserted. There's a wiring diagram for an auto power off relay, wiring diagram for power loss recovery. So you would get a separate board for power loss recovery, how to wire up your RGB lights. So there's a ton of information inside of this manual that you're going to want to read through, and I'm going to want to read through to make sure that everything gets connected just the right way. So for now, what I'm going to do is I'm going to start by bench testing the Manta E3EZ. I'm going to connect the DC power to it, and then from there I'm going to start configuring the CB1. I'm going to connect it to the HDMI 5 touchscreen, get everything working, and then from there I'm going to take one of the stepper motors and I'm going to start connecting the drivers, and I'm going to check each one of the motor outputs with that stepper motor to make sure that all of the pins and configurations and whatnot are correct before I go and install this into the machine, because you never really want to just start installing a board, connect all the motors with the belts and everything attached, and have the thing go Skynet on you. You want to make sure that it's working properly before you go setting it up with mechanical movement to prevent any kind of collisions or any kind of dangerous situations. So I'll spare you the harrowing details of trying to remove the CB1 from the Pi 4B adapter, because most of you will be buying a new CB1. But let's just say to get it off, I just took my screwdriver, put it under here, and pried up gently. The CB1 comes with these little plastic screws to secure the CB1 to the Pi 4B, but they don't work with this board. The Manta uses these 4 M2 standoffs to mount the CB1, where the Pi 4B uses M2.5 screws, which are a larger diameter and thereby won't fit. According to the literature, I should have these screws, but I don't, so I'll have to find something that'll work. When you're installing the CB1, make sure that the pin headers line up with the ones on the Manta and that it's facing the proper direction. It's hard to put the thing on backwards, but you never know. As mentioned before, the SD card with the Linux distro will be plugged into this slot here. I do have the CB1 distro on this 32 gig SD card, which should be the same as the Manta board, so I'll start by using that. It does stick out quite a bit when you insert it, so be careful of that and just be aware of it when you're designing any mounts or adapters for your printer. I've got this barrel connector that I'll be using for now with the 24-volt supply I purchased when I was running the MKS Pis before they went Skynet and stopped working reliably. So I'll use that to power the Manta while it's on the bench. Okay, I've got the Manta wired up to the 24-volt supply. I've got the HDMI 5 connected, so let's see if it fires up. and it does not. So I'm not going to yank your chain and bullshit you into thinking that I didn't have any snags getting this thing to run, but ultimately it just boiled down to when you insert this board onto the 2 pin headers that are underneath the CB1, you have to kind of rock it back and forth and give it a little bit of brute force, or else the pins don't seat properly and the thing just doesn't come up. I had thought at one point that I had received the wrong Manta board. I thought that I received the Manta board for a CB1 V2.1 and I have a V2.2, but that wasn't the case. It took me a good half dozen tries, and finally I just gave it a good squeeze, and I felt everything kind of seat in properly, and now I can affix it with the screws once I get some M2 screws to screw it down. I actually thought that I had screws that came with it, and I said, oh boy, I was dumb, and I took them out of the bag, and they're 2.5. So I have to get some M2 screws to secure this thing to the board, and then from there I can kind of throw it around like a frisbee and nothing will come unattached. So what I'm going to do at this point is I'm going to get the printer CFG that loads onto here. That is for the E3EZ. There is actually a printer CFG that is pre-packaged, so that's going to make things a little bit easier. I'm going to start connecting the drivers, I'm going to start connecting some of the motors, and I'm going to test everything as it sits here on the bench before I start assembling anything onto the machine. You always want to make sure that your motors and stuff are working and everything is reliable before you go and assemble your machine, because you don't want the machine to go Skynet on you and break something. It's better to test all your motors and such on the bench, make sure that everything's on the up and up. So the first thing I have to do is open up an SSH session now that the Manta is up and running and change the host name, because the CB1 currently thinks it's a Neptune 3. So I'll go into my Windows command prompt and I'll type in SSH Neptune 3 -L with the username of BQ, and -L is just a login with the username. Put in the password, and then it opens up. From here, I'll go sudo nano/boot to open up the boot folder /system.cfg. And from here, I can cursor down to where it says host name. I'll change Neptune 3 to Chiron. I'll come down to the keystone angle. And for right now, I'll put that in landscape mode. I'll change right to the word normal. I'll do a Control X. It'll ask me if I wish to save. Hit the letter Y for yes. Then it'll ask me for the file name. And because I opened it up by the file name, I'll just hit enter. It exits out. And then I'll do a sudo reboot now and just wait for it to reboot. And because I'm impatient, I typically will type in the word ping, put in the new host name, hit enter. And if it doesn't register, it'll time out. Just press the cursor up button, hit enter again, and we could see that chiron.local is pinging, so now it's back up. Close this out, open up my browser, and go to chiron.local. I don't have the right printer CFG file in there yet, so I'm going to go to New Tab, and I will look for Manta E3EZ, get to their GitHub page. If I come down to firmware, under Clipper, there is a generic Bigtreetech Manta E3EZ CFG, and there's an Ender 3 CFG. Not that it really makes that much of a difference. I think the files are pretty much the same. But if I click on here, it opens up the generic file that I would use to start getting the board configured. If I hit the copy raw file here, it'll just copy all the raw data from here into copy buffer. I can't download from here because it will spit out an alarm at me because it's a CFG file. So I'll just copy that. I'll go back to here. I'll go to the menu bar, down the machine, and then I'll go into the printer.cfg. Open that up. Control A to select all. Control V to paste what I have in the paste buffer. Save and restart. I probably have to change the device. So I'm going to go back into my SSH session. And from here, I'll just do an ls/dev/serial/by-id/star. and that will give me the full ID that it's currently looking for to connect to the board. Do a Control-C to copy. Go into Printer CFG, come down to here, and we can see that right now it's 1, 2, 3, 4, 5, and the one that I have is for a Huracan. I believe that there is a way to change the serial by ID, but for right now I'll just keep a Huracan and take it at that. Save and restart. And at this point it should start to, see right here it starts to connect. It's giving me a shutdown. It says ADC is out of range. Heater temperature exceeds its configured min temp or max temp. So right now, I don't have a thermistor attached to the board. So this kind of makes sense that it's not registering anything at all. It's not registering any kind of resistance. So that does make sense. So I'm going to plug in a thermistor and do a restart and see how it works. But essentially, it's on. It's working. Everything is loaded up, and I think we'll be in good shape from here. So now I can go back to setting up all the connections and get into bench testing. So before I begin bench testing, I want to do a brief overview of stepper motors. Here we have what would be your typical bog standard two-phase bipolar stepper motor. This is the extruder motor from my Elegoo Neptune 3, but this type of motor can be found anywhere, from Slamazon to AliExpress. Hell, you can sometimes pilfer an old inkjet printer for one. The downside to these motors is that there's no real standard as to what pin goes where on each of the two phases that drive the motor. There's an A phase with a positive leg and a negative leg, and there's a B phase with a positive leg and a negative leg. If you don't connect the phases together properly, you can get unexpected behavior such as grinding, buzzing, or in the worst case scenarios, you could potentially blow something up, and we don't want to do that. To add to this confusion, the motor output pins tend to vary as well. One example would be the Bigtreetech Manta E3EZ motor pinout order versus the Bigtreetech Octopus. This can be rectified by checking the pinout diagram for each board prior to connecting the stepper motors, but in a lot of cases you'll have to either acquire the proper cabling or make one yourself. If you're unsure of what pins connect to what phase on your steppers, there's a few ways you can figure this out. The first way was covered briefly in my Creality eFit installation video, where you take a piece of wire with DuPont connectors on each side, connect the wire between the pins, and try to turn the motor shaft by hand. If you feel jumping or cogging in the motor, you have the correct pins for one of the phases. Repeat this, and you'll eventually find the pins that connect to each of the phases. Another way to test this is to take two DuPont wires and an LED, plug the LED into one side of the DuPont connectors, connect the wires to some of the pins, and turn the motor shaft. If the LED lights up, you know you've got the correct pins for the phase. Repeat this until you find the other phase. The third way is to take a multimeter, set it to the resistance setting. In this case, the resistance setting has an audible beep. When the probes are not connected to each other, you see OL. And when you touch them together, you not only get an audible beep, but the display shows 0.0. With this, you just touch the pins with the leads and just listen for the beep. And then repeat that on the other side, this pin here, and this pin here. As mentioned before, the EZ2209 drivers are designed in a way where you can only insert them in one direction into the EZ slots. You can tell not only by looking at them from this view, where you can see the little angle here, but also looking at them from this view here, if the camera would focus. There's a little notch on one side of the heatsink that lines up with a little notch on the boards themselves. So I currently have the two thermistors plugged in for the bed and for the hot end. That brings up the board and it doesn't give me any error messages. And now I'm going to plug in the EZ driver into the slot. I've got a short motor lead that I'm going to use to connect the stepper motor to the X-axis here on the board. So I'll begin by plugging one side into the board, then take the other side, plug it into the stepper, and then power on the Manta. Okay, so I've got it all connected. I've got it all powered up, and let's try it out. Let's go to Move. I'll try and Home X. And it does start to move. It's not making any shaky noises or anything like that. It says end stop X still triggered after retract. So I probably have to hook up some home switches and things to this board or figure out a way around this. I know that there's the force move setting, but I'll try and see if I can get that to work. And if so, it'll be part of the video. Okay, so I've got force move enabled inside of mainsail. You have to do it through a console command. I can't find the icon that lets me just do it. So let's do it through the console. I've got force move, stepper X, a distance of 100 millimeters at a velocity of 100. So let's see if this thing spins. And there it goes. So we've got the motor spinning. Not sure if it's the right direction or not, but we do have the motor spinning, which means that the motor connections are proper. We don't have to crisscross any wires. We just follow this convention here when wiring up the new motors, and we should be all good. I did test the motor out on the original control board with the original firmware, and I was able to move the machine around. I was able to move this motor around. So that leads me to believe that all of the motors are wired in the exact same fashion. So all of them should follow the same wiring convention. So I'm pretty happy with what I see so far. I feel a lot more comfortable moving forward with this now that I've got a motor spinning. I can put all of the drivers in their respective locations, and then upon assembly, I'll disconnect all of the major drive components and just spin the motors by themselves before I hook up the screw couplers and the belts and what have you prior to getting this thing actually zipping around. But this gives me a warm and fuzzy that we're headed in the right direction. So that'll do it for this video. Thank you for watching. If you haven't subscribed to the channel yet, please make sure you do. Throw a like on the video to help boost the algorithm, and stick around for part 3.